Very well. So we're going to introduce the concept of series today. Recall that from previous lecture, we talked about sequences. What is a sequence? A sequence is a function, am I right? Is a function. For this function, we have fn, which is equal to a sub n. And remember that for this function, the domain is either natural numbers or you're working with the whole number system with domain equals to n or whole number system. For example, suppose I give you these two sequences. The first sequence is example. The first sequence is this sequence. an is equal to n. And the second sequence that I'm giving you is bn equals to 1 over n. So I'm giving two sequences for you to check. Well, what are the terms of this sequence? Well, you say that if n is equal to 1, a sub 1 is 1. If I plug in 2 for n, the second term becomes 2. If I plug in n equals to 3, the third term becomes 3, and so on. I can continue this process. So if I ask you to find the sum of the first n terms, what are you going to do? You're going to start adding these numbers. You're going to add a1, a2, a3, and the rest of them. You denote it by s sub n. So s sub n, as we introduced yesterday, is the sum of the first n terms of this sequence. We call it the partial sum. Partial sum. Well, when you're talking about the partial sum, you might use a different notation. You might say that, hey, I'm going to use, for example, k. Absolutely fine. You can say that s sub k is the partial sum of the first k terms. The sum of first k terms is denoted by s sub k. So what are you going to do? You're going to take the first k numbers and add them together. The representation that you're using is the sigma. Capital sigma represents the sum. So when I ask you to write down the sum, mathematically, you're going to use the sigma notation, the Greek letter, we call it sigma. So this sigma has some starting value. The very first value is n equals to 1. And suppose you want to stop at the kth terms. So stop at n equals to k. And then you're going to copy down the general term with the same index that you have. So for example, you can write it this way, and this becomes a sub 1 plus a sub 2 plus a sub 3 plus the rest of the terms until you get to a sub k. So this is the partial sum. Sk is equal to a1 plus a2 plus a3 plus a4 plus the rest of the terms, and you're going to stop at the kth terms. This is the partial sum. Mathematically, we represent it by series. This is sigma, so this is called a series. So this is the series notation when you're just adding values, adding terms, adding numbers together. So for example, in this case, suppose I ask you to find, let's erase this one, then we're going to discuss that. Suppose I ask you to find the sum of the first three terms The first three terms, okay. Three terms. The first three terms. The first term is A1. The second term is A2. And the third term is A3. We denote this by S sub 3. Mathematically, we write it as the sum sigma A sub n starts from 1 and stop at 3. N start from 1 and n stop at 3. So what is this sum? We already know these values. It is 1 plus 2 plus 3, which is 6. So if I ask you to find the sum of the first three terms, mathematically, you write it this way, and you need to be able to calculate this because you already have all of these values for the terms of this sequence. So from a sequence, we define a series. Another one, suppose I ask you to find the sum of the first four terms. What is the sum? The sum of the first four terms. So what are you going to do? You're going to write down S sub 4, which is defined as A sub 1 plus A sub 2 plus A sub 3 plus A sub 4. Mathematically, you're going to use the sigma notation. This is equal to the sum. N starts at 1 and it stops at 4 of the general term A sub n. Well, can I calculate this? Can I compute this? Of course, A sub 4 is equal to A1 is 1 plus A2 is 2 plus A3 is 3 plus what is A4? A4 is just 4. So if I add this together, I already know that this sum is equal to 6. 6 plus 4 is 10. So we found the partial sums of this sequence, which gives us the definition of the series. So now I have a question for you. What if I add all of these terms? Question. What is A1 plus A2 plus A3 plus the rest of them? I'm not going to stop anywhere. I'm just going to continue adding these together. What would be the final answer? Is it going to be a number or is it going to infinity? So if I ask you to add all of these numbers together, instead of creating a partial sum, instead of adding this partially, I'm just going to ask you to add all of these together. It means that I'm asking you to add 1, 2, 3, 4, the rest of the terms, 5, 6, and the rest of these. This number is getting very large. This goes to infinity. In this case, we say that the series is divergent. So if the sum of the series goes to infinity, you're going to say that the series, this series, the sum n start from 1 to, I'm not stopping anywhere. I'm going to infinity does not exist or goes to infinity. And we say that, hey, the series is a divergent series. Let's go over another example. So now I'm going to work with this sequence, bn equals to 1 over n. Remember that we start by defining a sequence. bn is equal to 1 over n. If I ask you to list the terms of this sequence, you're going to say that if n is equal to 1, from the domain, b1 is 1 over 1 or just 1. When I take n to be 2, b sub 2 is a half. When n is equal to 3, b sub 3 is a third. When n is equal to 4, b sub 4 is a fourth, and the terms of this sequence continue. There we go. So we have this information about this sequence. It doesn't give us anything else. We can just graph this, take a look at the graph. Remember that here for this sequence, the graph was like this. This is what we graphed last time. And here you have Bn 1 and 1, 2 and a half, 3 and a third, and you can continue this process. You can graph this sequence. And as you can see, it's getting closer and closer to the y value equal to 0. So this is the end behavior of your sequence. So the end behavior of the sequence is that the Bn is getting closer and closer to 0, the end behavior. Okay. We saw these graphs before. It's similar to the behavior of 1 over x on the positive side of x-axis. Well, now I'm telling you, hey, I want you to add some of the terms of this sequence for me. Now I'm moving to the next step. In the next step, in this new step, I ask you, well, guys, add the terms. I'm done with the sequence part. In the next step, I ask you to add the terms. Something new. This is absolutely something new. So what are we going to do? For example, I ask you to add the first n terms of this sequence, s sub n, or the partial sum. You can again change these. S sub n can become, for example, s sub k. It doesn't matter. This guy is equal to a1, or in this case we have b, so b1 plus b2 plus b3 plus the rest of the terms, and you're going to stop at b sub k. So this guy can be written as the sum. N starts from 1 and stops at k. And I have the general term, which is 1 divided by n. Just copy the general term from Bn here. So this guy gives me the partial sum. For example, if I ask you to find the sum of the first two terms, nothing really complicated. You're going to write it this way. You're going to say that, hey, I have s sub 2, the first two terms, which is b1 plus b2. But what is b1? b1 is 1, b2 is a half. So this is equal to, well, I have 3 halves. Am I right? 3 divided by 2. What if I just ask you to add the first 3 terms? What is the sum of the first 3 terms? What are you going to do? You're going to take s sub 3, add b1, b2, and b3. This is 1 plus a half plus a third. So this guy becomes, well, I already know that this sum is 3 halves plus a third, which gives me, well, here I have 6, 9 plus 2, or 11 over 6. I can continue this process. I can take more terms and add them together. So this is 3 halves. Let me write it down here. And for example, find the sum of the first 4 terms. The sum of the first 4 terms. Well, it's denoted by s sub 4, which is equal to b1 plus b2 plus b3 plus b4. S sub 4 is equal to s sub 3, s sub 3 plus b4. I already know what s sub 3 is. S sub 3 is 11 over 6. So S4 is 11 over 6 plus B4. But what is B4? 1 over 4. If I take the common denominator between these two, the common denominator, I'm looking for the least common denominator, which is 12. This is 22 plus 3 divided by 12. So I get 25 over 12. So I can continue this process. I can find the sum of these terms and define something new that we call the series. This is the series, the sum or the series. And here we have the partial sums of this series, partial sum. Now let us talk about the sum of an important series, geometric series. Geometric series. Very good. A geometric series is defined this way. We say that, hey, I have, well, the very first term, which is a sub 1, plus the second term, which is a sub 1 times the common ratio, plus a sub 1 times the common ratio squared, plus a sub 1 times the common ratio to the third, plus the rest of the terms. So we are having these terms written here, and we are adding these together. This becomes the sum of a sub 1 and r. This is r to the power 0. So if you want to write this with an exponent, the exponent becomes n minus 1, and n starts from 1 to infinity. This guy is called a geometric series. This series, this sum, is convergent to a1 divided by 1 minus r if r, or the common ratio, is sandwiched between -1 and 1. And this series, or the sum, is divergent if r is larger than equals to 1, or r is less than equals to -1. So again, this is an important definition, geometric series. When we have a geometric series, we define the terms of the geometric series this way: a1 plus a1 times r. Remember that r is called the common ratio, r, or the common ratio. So this is important to notice that this series, this sum, which we denote by sigma, the summation notation, a1 r to the power n minus 1, n starts from 1 to infinity. It means that we are just adding these terms together and we are not stopping anywhere. This sum is going to be convergent to a number. What is that number? a1, the very first term, divided by 1 minus the common ratio if this condition is met, if your r is a number between -1 and 1. And again, this sum is going to infinity. It's calling divergent if your r is larger than equals to 1, or r is less than equals to -1. Well, let us take a look at one example. Suppose I ask you to find the sum here. Well, here we have this term. Let's write one example and then we're making it more interesting. Example. Find the sum. It's given to us as, well, the sum 1 over 10 to power n, and n starts from 1 to infinity. Okay, take a look at this. What do we have here? We have, well, if n is equal to 1, it becomes 1 over 10 plus. Next number is 2. If n is equal to 2, I get 1 over 10 to the second power plus. The next term is 1 divided by 10 to the third power plus the rest of the terms. Guys, as you write down this series, you need to check and compare it with the original definition. Very well. So what do we have here? It says my first term is 1 over 10, and my second term is 1 over 10 times 1 over 10. My third term is 1 over 10 times 1 over 10 to the second power. So it seems that my A1 is equal to 1/10, and the common ratio is just 1 over 10. So is 1 over 10 a number between -1 and 1? Since 1/10 or R is in between -1 and 1, so we have a convergent series. So we have a convergent series. It means that I can find the sum using this formula. So sum 1 over 10 to the n and start from 1 to infinity must be equals to this guy here, which is A1, but A1 is just 1/10. 1/10 divided by 1 minus 1/10. 1 minus R. Now we just do the algebra. 1/10, and here if you take common denominator between these two, you get 10 minus 1 divided by 10, you get 1 over 9. Remember that here you can easily cancel out the denominator on the numerator and the denominator on the denominator. So it says, hey, this sum, if I keep writing these numbers, 1/10 plus 1 over 100 plus 1 over 1,000 plus 1 over 10,000 and the rest of them, actually it gets to the 4th, okay, and then to the 5th, to the 6th. The sum is getting closer and closer to 1 over 9. This is an example of a geometric series where the common ratio is bounded between 1 over 10. Again, guys, you need to remember the definition when you write the series in expanded form. So this is the expanded form of the series. Expanded form. And this is the compact form or series form. Compact form and expanded form. When you take your series, write it in expanded form, compare it with the definition. The very first term is 1/10 plus. Well, sometimes the very first term and the common ratio are combined together. Our job is to identify those A1 and the common ratio. Then you check the definition. The definition says, hey, my series is a convergent series if the ratio is bounded between -1 and 1. So since R is 1/10, it means that 1/10 is bounded between -1 and 1. So I can follow this definition, follow that it's convergent to A1 over 1 minus R. I can do the computation. I can say that, hey, if I add these numbers together, the sum is equal to 1 over 9. Very good. Let's take a look at this example. Question says, find the sum find the sum of, now I'm going to change this and write it as the sum 3 divided by 10 to power n and starts from 1 goes to infinity. Well, what's the difference between this example and previous example? In previous example, we had the following case. We had the sum. It was just 1 divided by 10 to the n and starts from 1 to infinity. The number on the numerator was just 1. So you have an important properties for series. If you have a series that it has a number, a scalar, a value like c times the general term a sub n and start from 1 to infinity, you can actually take this constant, take this scalar and write it in front of your series. So you can write it this way. You can say that, hey, this guy is nothing but c times the sum an and start from 1 to infinity. You can always do that. As long as your c is just a number or a scalar, you're allowed to do that. You can take c and write it in front of your series. Guys, know that I have multiplication. C is multiplied by an. So what I'm going to do, I'm going to take 3 and write it in front of the series. So I have the series, 3 goes in front because it's just a scalar, and I end up with 1 divided by 10 to power n and start from 1 to infinity. Or I can write it this way. I can write it as 3 times 1 over 10 plus 1 over 10 squared plus 1 over 10 to the third plus the rest of the terms. But I already know this is a geometric series. For this part, we know that. We know that R is 1/10, and the 1/10 is between 1 and -1. I already know that the common ratio is bounded between 1 and -1. What's the meaning of that? It means that this series is convergent to this number here, a1 over 1 minus r. Don't forget your 3. So this guy becomes 3 times 3 parentheses. Well, what is a1? a1 is 1/10, the same as before, divided by 1 minus 1/10, which is 3 times 1/10 divided by 9/10, or if you cancel out 10 and 10, you get 3 divided by 9, or a third. So this is the sum of this series. You say that, hey, my series, the sum 3 divided by 10 to the n and starts from 1 to infinity is nothing but a third. If I add all of these numbers together, it approaches to a third. Very good. Now, suppose I give you this guy. I'm telling you, hey, check this series. I say, I have this guy here. I have 3 to the n divided by 10 to the n. Well, it's not a constant anymore. It's not a scalar anymore. It has an exponent. I'm not allowed to take this outside series. So what should I do? Well, what we can do is to combine these two. 3 to the n divided by 10 to the n is 3 over 10 to the n. Well, take a look at this. So this series becomes the sum 3 over 10 to the n and starts from 1 to infinity, which is 3 over 10 plus 3 over 10 squared plus 3 over 10 to the third plus 3 over 10 to the fourth plus the rest of the terms. Compare your series with the definition. A1 is 3 over 10. And at the same time, your R, the common ratio, is also 3 over 10. Check to see if your common ratio is bounded between -1 and 1, which is 3 over 10 is bounded between -1 and 1. So following the convergent geometric series, the sum is, equal to A1, which is 3/10, divided by 1 minus 3/10. The rest is algebra. We copy down 3 over 10 divided by, if you take common denominator, you get 10 minus 3 divided by 10. Of course, you can cancel out the same denominator on the numerator and on the denominator, and this guy becomes 3 over 7. You say that the sum of this geometric series is 3 over 7. Very good. So now what if I change this? What do I mean by that? What if I write it this way? As 10 over 3 to the n. Guys, I'm flipping the fraction. 10 over 3 to the n. Well, is this a geometric series? Okay, let me check. This guy can be written as the sum n start from 1 to infinity is 10 over 3 plus 10 over 3 to the second plus 10 over 3 to the third plus the rest of the terms. So what is the first term? My first term is just 10 over 3, the same first term. Okay. And the second term, which is 10 over 3 to the second, 100 over 9. And the ratio, common ratio becomes 10 over 3. Is 10 over 3 bounded between -1 and 1? Of course not. 10 over 3 is larger than equals to 1. Am I right? So what's the meaning of that? It means that we cannot find any sum since this series is divergent. So this is your final answer. You say that the series is a divergent series and it doesn't have any sum of this form. We are not allowed to use this formula here. This is a divergent series.